Ladies and gentlemen, it is my pleasure to introduce you to today's presenters, Mr. Willie Peter Schaub and Mr. Garrett Besser. They are working with the DB&D Microsoft Technology Unit, and I let them tell you more about themselves and the section in just a second. Willie and Garrett, it's all yours.
Thank you. Good evening from South Africa. Garrett and I would like to welcome you to our webcast exploring our perspective and our findings of the Windows Communication Foundation as early adopters. We will briefly position Windows Communication Foundation, then give our findings to date, present our personalized roadmap to WCF, and then finish off with a hopefully simple demonstration. WinFX is an extension of the Microsoft.NET Framework and combines the power of the .NET Framework 2.0 with new technologies such as Windows Workflow Foundation, Windows Presentation Foundation, InfoCard, and the Windows Communication Foundation, formerly known as Indigo. WCF is a unified framework enabling us to build secure, reliable, service-oriented applications that integrate across platforms and interoperate with existing investments. WCF combines the capabilities of existing Microsoft technologies such as ASMX, WYSI, and Enterprise Services, and supports the WS Web Services protocols for broad interoperability across heterogeneous platforms.
Our general perception of WCF up to and including Beta 2 can be summarized as follows, whereby I am presenting the skeptic and Willie the enthusiastic adopter. Feature, code, and documentation churn has been high across recent releases, currently making the adoption of the technology a challenge. We expect, however, that the migration to future releases will be near seamless. The lack of, and especially integration of, WCF with Visual Studio specific administrative and maintenance tools is impacting the productivity. We expect these tools to be created and released by the product teams when WinFX on the RTM phase.
On the good side, the WCF product team has managed to provide a service-oriented development model which supports the core service-oriented concepts of message passing, schema, contract, and policy. The contracts include explicit service contracts, data contracts for defining the shape, rules, and versioning for data and message contracts. The reliability support includes in-order and exactly one guarantees, and transactions by default communicate with Web Service Specification compliant protocols. The abstraction of security and standard-based interoperability has decreased the need to develop thousands of complex lines of code to decorate the WCF code with attributes or by configuration. The unified and productive development model allows us to develop SIA-compliant solutions efficiently and effectively. In fact, we merely have to worry about the ABC, A for address, B for binding, and C for contract. In other words, configuring the where, the how, and the what.
Looking at actual interoperability and productivity, our findings vary as follows. X509 certificate-based security is still tricky to set up and use in a development environment, bringing back some sleepless nights from pre-WYSI and WYSI days. Third-party interoperability is unfortunately dependent on WS star standards compliance, and we have found discrepancies between vendor implementations of the WS standards. There is currently no integration of WinFX with Visual Studio Team System, and it is therefore not possible to model solutions that contain or integrate with solutions using WCF technology.
The great news is that the interoperability with existing Microsoft distributed computing stacks, such as MSMQ and Enterprise Services, is seamless and usually achieved by configuration and by running proxy generators. Although performance is not spoken about by the product teams as yet, we have noticed significant improvements in the ASMX and the remoting environment. The roadmap to WCF is simple. If you can make use of WCF, use it. This decision chart shows that we need to first decide whether we are targeting the .NET 2 framework. If, for example, we are targeting .NET 1 or some other technology, we will be forced to use Web Service Enhancements 2 or some other third-party technology. If WCF is stable, in other words, it demonstrates low churn of code and functionality and is supported either through a release or by the Enterprise Go program, we urge you to make use of WCF. If this is not the case, please utilize Web Service Enhancements 3, which allow a near seamless migration to WCF. To end the presentation part, we have included a list of references and our contact details. Please make a point of looking us up and giving us feedback. Like Garrett, can you just give us a quick wrap-up of what we will be building in the next 20 to 30 minutes?
Cool, Willie. We would now like to switch our attention to a quick demo. The business analyst will frown because the demo was designed to demonstrate the following features: hosting of services, one-way calls, duplex calls, transactions, session management, and reliable messaging. In essence, the client calls the service with an init request, a calculate request, and completes with the complete requests. The calculation result will be returned asynchronously. Let's go and demonstrate these tenets with a simple demo.
Right. Let's explore the solution, which exists of three projects, namely Calculator, the service, the client project, and the contracts project, in which we will define the data and the interface contracts. The contracts assembly is referenced by the Calculator service. Firstly, we define the service contract consisting of one-way method calls. And the callback interface. Take note of the service contract and operation contract attributes, which are used to define the service and operation contracts respectively. We then update the data contracts, whereby the service and data contract can be defined in sequence of preference. Again, note the use of attributes to define the contract. In this case, data contract and data member. If we would implement a message-based solution, we would use message contract instead. Let's build the project and ensure that we have no gremlins lurking around. How we implement the actual calculator service. Let's modify the program CS class in the calculator project and host the iCalculator interface. The snippet has implemented skeleton codes for the interface methods init, calculate, complete, and complete session, as well as a service host implementation code in the main entry point. Note that we normally would implement the host separately from the service code to ensure loose coupling and extensibility. Let's compile the calculator project and to ensure that we have no syntax errors. We then update the application configuration file named file app.config of the calculator project. Have a peek at our WCF Indigo configuration posters on www.drp.co.za, on which we try to summarize the structure and key configuration options relevant to WCF. This configuration file now defines the ABC, i.e. the address, the binding, and the contract for the service. Let's build and set the calculator as the start project and start the calculator solution to verify that all is in order. So what are the problems so far? As yet, we have not implemented the calculation functionality because we need to remember the values passed by init before the calculate method is called. As the code stands, the information or state is lost with each method call, as WCF creates a new instance on each invocation by default. Also, we have no control on which method is invoked in which sequence, which could lead users calling complete, then calculate, then init, which would be an issue. To start off, let's update the iCalculator interface, defining the service contract consisting of one-way method calls to indicate that we require a session, and to control the sequence of method invocation. We also indicate when a session is created and terminated by the service host of the interface. So what we currently are defining is the sequence, namely that init must be called first, followed by calculate and or complete, and complete session must be the last, as it will actually terminate the session. We then update the configuration file of the service to enforce flow. Note that session is enabled implicitly with a dual HTTP channel. We then update to implement state in the calculator service class, where we indicate the context mode using an attribute. Finally, let us extend the request and response object to support caching by implementing the iExtension interface. We will not utilize the attach and detach methods of the instant context extension in this case, but instead implement empty methods to satisfy the iExtension interface contract. Finally, we can implement the actual logic in the calculator service. First, we implement the init method, which instantiates a context and adds our calculation request to the active session. Next, we implement the calculate method, which retrieves the request from the session and performs the calculation, and finally adds the response to the active session. Next, we implement the complete method, which retrieves the response and the callback treasure map and returns the result via the asynchronous callback channel. Lastly, we write to the console in the complete session method to indicate that the session is terminating. Let's rebuild again and validate that all is in order. Please note that WS bindings by default implement message security, so there is no need to further secure the data. However, to move from WS dual HTTP binding to net TCP binding, for example, requires no recoding, merely a change of the B for binding in the application configuration file. Let us quickly enhance the service to include support for WS atomic transactions so that we can generate the proxy and configuration files with all the bells and whistles included for the client. First, we need to add the transaction attribute on the calculate member of the iCalculator interface. Again, we're using an attribute, this time indicating that transaction flow is allowed. We then do the unthinkable and change the contract, because a transaction across a one-way call makes no sense and is not supported by Indigo by default. Next, we implement the transaction scope in the service by adding the operational behavior attribute to the calculate method. Again, we use attributes to indicate that we require a transaction scope and that transaction autocomplete is true. Let's rebuild and run, just to be safe. And unthinkable. Right, let's build it again. Well, this demo gremlin has just proven that we should never ever change a contract.
Right. Let me take control. You watch my typing, and I will implement the client that will consume the beast we have just developed. First, we start the calculator service. Then we switch to the command line and generate a proxy using the service util utility. Note that we are generating a proxy and configuration file from the services WSDL without any web server serving the WSDL request. We add the proxy as a linked file to the client project. Let's update the application configuration file content. Once again, peruse our WCF/Indigo configuration poster. We also give the endpoint a name. Take note of the client base address configuration, which defines the callback address. By default, the client base address defaults to port 80. Let's modify the code in the program.cs module of the client project. We see in our constructor that we initialize a new instance context and pass in our calculator callback, which is what our calculation client implements. We'll initialize the calculator proxy with this context, passing in the name of our calculator service as defined in our configuration. We see public void result is our asynchronous callback, where we read out the result passed back from the server. In our process function, we instantiate a request object, we populate the values, and most importantly, we call init before calculate because that is initiating according to our order of our functions. Then call calculate, passing in our request, and calling complete. Next, we're going to implement a transaction scope that will call our process function. Great. Note that we've got client.complete session after our transaction scope. Let's build the client project to confirm the absence of any syntax errors. Okay, let's just put in our namespaces and rebuild. Great. Okay, let's modify the startup project properties of our demo solution to start both the service and the client. Okay. Let's select debug and then start debugging from the Visual Studio menus. When our service is running, let's enter a keystroke into the client console. We now see the calculation going through the mysteries of Indigo and the result coming back via the callback channel. we have explored the following core features in this demonstration: hosting the WCF service in a simple console application, state management, transaction scope, and duplex communication using callback interfaces. To conclude, let us change the sequence of method calls to see what happens, thereby violating our order of our functions. We call calculate before init and see. We see that the service rejects the request. The exception indicates that we trapped an invalid operation exception, specifying that the order of the service request is incorrect. Let's switch back the code and ensure everything is happy again. Great.
Right, to summarize, we have covered the following in this webcast: a brief positioning of WCF, our perception of WCF to date, which is very positive, our own roadmap to WCF, and with a simple demo, we have hopefully illustrated the ease and the power of the WCF development environment. We thank you for your attention and hope that we will be able to share our passion and excitement for WCF with you.
Well, thank you very much, Lillian Garrett. As Lillian Garrett mentioned, I've just gone through the summary and now they're actually open for questions. I just had a few more pieces of information to share with you before they take your questions. The recording of this session will be available in 24 hours at www.microsoft.com/webcast. If you have any webcast content ideas, we'd be happy to hear from you. The URL for contacting us is on the screen right now. And also, today's webcast was presented using Microsoft Office Live Meeting. You can try it yourself for 14 days free of charge at www.microsoft.com/presentlive. I'm about to launch the survey for the session. Please note that if you do fill out the survey, your name would be entered for a drawing for a portable 40 gigabyte MP3 WMA player. We give 10 of those away each month, so there's a good chance that you could win. So please fill out the survey and let us know how we could do even better next time around. Lillian Garrett, back to you so you can answer questions at this point.
Thank you. We've got two interesting questions. where can you get the code? What we will be doing in, well, I think tomorrow morning for us, and probably today, or this evening for you, we will be uploading the source code and the script to our DRP site. So it's www.drp.co.za.
Well, can you go ahead and type that in and post to all so everyone can see that URL, please?
Okay, I'll type that out. Garrett, do you want to take the instance context question? I'll type. Thank you.
Thanks, Willie. Just bringing up the code over here. Yes. Because we are using session-based in our demo, we are serializing our request and our response objects to the instance context that we're using per session. If we look at our calculation request, we see that we've added some attributes, the data contract and data member attributes. These tell this tells WCF what we need to serialize on the wire. So if I just pull back here to the implementation of the actual code in the calculator service, I take the operation context, which is our singleton, .current.instance context, .extensions.add. And what I'm adding is I'm adding the calculation request that was passed into the service function. Then on the calculate, I find our calculation request in the instance context extensions. Similarly, in the complete, I get the response out that was added at the end of the calculate function, and I return that asynchronously back to our client.
Looks like there's a couple more questions for you guys, if you wanted to answer them.
Sure.
Since the attendees can't read the questions, would you mind reading them out loud and then responding?
Sure. Well, let me redo Justin's question. Justin J asks, what is instance context? Where did the request and response object come from? And the answer is instance context is the context of the session. The request and response objects were created by us and then added to the instance context. We then pull these and added to the context of the calculator in the initialize method and retrieved it in the calculate and complete methods, doing a similar implementing similar functionality with the response object. Hello. So we've got to ask of C. Besides reading your book, could you list some online resources to get up to speed on this area? Okay, well, the answer to that one is there is extensive documentation on the latest WCF SDK. Which ships as part of the WinFX SDK. ensure you install Beta 2, most definitely. We've got a question here from Yuval. Is the request an Indigo object or an HTTP request object? The request, are you referring to the request message that we populate on the initialize function? Request is the request message is our custom data contract, and thus is an Indigo object. It is serialized and transmitted via SOAP. It is transmitted via SOAP by default, but we could, if we wanted to, switch this over to binary. Chuck asks a question. You demoed ordering rules for first and last methods. Is initiating, is terminating. Are there ways to force ordering of method calls besides simply first and last? Not as far as we are aware at this stage. We can specify first, last, as well as services, service calls in between. But as far as we know, it's is initiating and is terminating. That starts the session and brings the session down. On top of this, we can also enforce ordered messaging. We can do this through the configuration channel in addition, which will ensure that messages cannot go out of sync. We've got a question here from Amit Modi. When the communication is stateless, how does WCF enforce the sequence of service operation calls? Okay, so we need to investigate the plumbing. However, what we have tested is that the first, last, and intermediate messaging works with stateless sessions. Thanks for the questions. That's much appreciated.
Great. Well, it looks like you answered all the questions. Thank you very much for your presentation. Both Willie and Gary did a great job. And thank you, everyone, for attending. Ladies and gentlemen, this concludes today's MSDN Architecture webcast. At this point, please disconnect from the audio portion of this conference. Thank you.
Thank you.